cosmic crossroads, the science, scenarios, and stakes of potential extraterrestrial contact. Look up. The night sky, sprinkled with countless stars, has always ignited a primal question in humanity. Are we alone? For millennia, it was a matter of myth and philosophy. But today, armed with powerful telescopes, sophisticated probes, and a deepening understanding of life's potential, we stand on the precipice of a scientific revolution. The serious investigation into the possibility and potential consequences of extraterrestrial life. What if we're not the universe's sole inhabitants? What if, one day, evidence arrives, or they do? This isn't science fiction anymore. It's a complex scientific frontier we must explore. Welcome to the scientific reality of space invasion. Part 1. The plausibility why we're looking. The idea of alien life isn't fantasy. It's grounded in staggering numbers and emerging discoveries. Consider the Drake equation, a probabilistic framework. Our galaxy alone contains hundreds of billions of stars. We now know planets are ubiquitous. NASA's Kepler and TESS missions have confirmed thousands of exoplanet, many in the habitable zone where liquid water could exist. The ingredients for life, carbon, water, energy sources, are common cosmic currency. On Earth, life thrives in astonishingly harsh environments: boiling vents, acidic pools, frozen tundra. These extremophiles prove life is tenacious, adaptable. If it arose here, why not on an ocean moon like Europa, or Enceladus, beneath miles of ice, or in the methane seas of Titan, or on a rocky world orbiting a distant star? Our tools are evolving rapidly. The James Webb Space Telescope peers into the atmospheres of exoplanet, hunting for biosignatures, chemical imbalances like oxygen mixed with methane that might indicate biological activity. Missions are planned to directly probe icy moons. Simultaneously, SETI search for extraterrestrial intelligence, scans the cosmos for artificial signals, technosignatures that would shout, "We are here." The scientific hunt is active, global, and accelerating. The potential for discovery, microbial or intelligent, has never been higher. Part 2. The scenarios. What might invasion actually look like? The term invasion conjures images of hostile fleets, but scientifically, the reality would likely be far more nuanced, and the first contact scenario drastically shapes the implications. Let's break down the most plausible scientific possibilities. Microbial discovery, most likely first contact. Imagine our Mars rover drills into ancient ice and finds fossilized, unmistakably non-terrestrial bacteria, or the JWST detects compelling atmospheric biosignatures on Proxima Centauri b. This is invasion on a microscopic scale. The scientific impact would be seismic, proving life isn't unique to Earth. But the practical implications, primarily biological, planetary protection protocols become paramount. We must prevent contaminating pristine alien ecosystems with Earth microbes and vice versa. A potential invasion in both directions. The risk of alien pathogens, possible but unlikely to be adapted to Earth biology. The bigger impact is philosophical, our place in a biologically rich universe. Detection of intelligence, technosignatures. SETI picks up an unambiguous, repeating signal from a star system hundreds of light years away, or we detect evidence of massive engineering, a Dyson swarm partially obscuring a star, or unusual infrared signatures. This is an informational invasion. The signal itself isn't harmful, but its content and implications are world-altering. Deciphering it could take decades or centuries. The mere knowledge that advanced intelligence exists reshapes human culture, religion, politics, and our future aspirations. It forces a global conversation about who we are and how we might respond. Is it a beacon, a warning, or just cosmic noise? Artifact discovery, silent visitors. Find it in our own backyard. An ancient derelict probe enters our solar system, perhaps a Voyager-like craft from another civilization, millions of years old. Or we discover structures on the Moon, Mars, or an asteroid that are clearly artificial and non-human. This is an archaeological invasion. It provides physical proof and potentially revolutionary technology to study, but no living beings to interact with. The implications involve intense scientific study, potential technological leaps, and profound questions about the civilization that sent it and why they might have ceased to exist. Direct encounter highly speculative, least likely soon. A craft arrives occupied. This is the classic invasion scenario, but scientifically, it's the most improbable in the near term. Vast interstellar distances and the laws of physics like the light speed barrier make routine travel incredibly challenging. If it happened, motivations become critical: scientific curiosity, like our own probes, resource acquisition. Unlikely resources are abundant in space, expansion or colonization, benevolent intervention, or hostile intent. Our technological disparity could be immense, making defense or meaningful dialogue potentially impossible. This scenario demands serious consideration of planetary defense strategies and international protocols, though its probability is currently very low. Part 3: The Science of Preparedness and Impact. Regardless of the scenario, potential contact demands serious scientific and societal preparedness, detection, and verification. How do we confirm a signal or finding is truly extraterrestrial? Rigorous peer review, independent verification across multiple observatories, and ruling out natural or human-made sources, for example, satellites, atmospheric phenomena, instrument glitches, are crucial. False alarms are common. Confirmation must be ironclad to avoid panic or misinformation. Planetary protection. This is a well-established scientific discipline within space agencies' COSPER guidelines. For microbial discovery, it means sterilizing spacecraft to avoid contaminating other worlds, forward contamination, and quarantining returned samples to protect Earth's biosphere back contamination. Labs like those planned for Mars samples are designed as high containment facilities. Communication strategy: who speaks for Earth? How do we respond to a signal? This involves complex xenolinguistics, deciphering potential languages, xenopsychology, understanding alien motivations, international diplomacy. Organizations like the UN's Office for Outer Space Affairs (UNUSA) and the SETI Permanent Study Group work on protocols, but a globally agreed upon framework for response is still evolving. Planetary defense. While focused on asteroids or comets, the technology's kinetic impactors, gravity tractors, and detection networks like NASA's PDCO also represent our closest current capability to respond to a hypothetical physical threat from space. Vigilance near Earth is key. Societal impact studies. Scientists collaborate with sociologists, psychologists, theologians, and policymakers to model potential reactions. History shows even false alarms like Orson Welles' War of the Worlds can cause panic. Real contact could trigger profound psychological effects: fear, existential anxiety, religious reinterpretations, geopolitical instability, or conversely, unprecedented global unity. Managing information flow and fostering scientific literacy are vital. Part 4: The Profound Questions Beyond the Science. Beyond the protocols and probabilities, potential contact forces us to confront fundamental questions. The great filter: are we rare? Is the emergence of complex technological life incredibly unlikely? If we find only microbes, it might suggest the filter lies ahead of us. Perhaps self-destruction is common. Finding ancient ruins implies civilizations might not last. Finding no one is haunting humanity's maturity. Are we ready? Could encountering another intelligence, especially a vastly older one, shatter our self-importance or inspire us to greater heights? Could it force us to overcome our own divisions? Our cosmic responsibility, if life is rare, protecting it becomes a universal imperative. If it's common, understanding our place in a potential cosmic community becomes crucial. The pale blue dot perspective, our fragility and unity in the vast cosmos becomes undeniable, redefining life and intelligence. Alien life might be so fundamentally different, silicon-based, non-carbon, living in plasma clouds that it challenges our very definitions. Their intelligence might be utterly alien, making communication or even mutual recognition difficult. Conclusion: the search for extraterrestrial life is not a quest for invaders. It's a quest for understanding. It pushes the boundaries of astronomy, biology, physics, and philosophy. While the Hollywood space invasion is unlikely, the scientific reality, the potential discovery of life beyond Earth, in any form, represents one of the most profound turning points imaginable for humanity. It compels us to invest in science, to think globally, to protect our planet, and to ponder our deepest nature. Whether the first contact is a microbe, a signal, an artifact, or something beyond our imagination, it will irrevocably change our story. The universe is vast, ancient, and likely teeming with possibilities. The question isn't just are they out there, but who are we in the face of that cosmic immensity? The scientific exploration continues. We must be ready, not with fear, but with curiosity, rigor, and a commitment to our shared future on this pale blue dot. Explore the science. Stay curious. The cosmos awaits. Like and subscribe for more.